Let's go through LeetCode 214 shortest palindrome. For this question, it gives us a string S, and let's convert S to a palindrome by adding characters in front of it, and return the shortest palindrome you can find by performing this transformation. For example, this kind of AACAAA, right? You see, for this kind of string, the substring we start from 0 to the part we mark is already a palindrome, and there is an A on the right. So what we need is that we just need to append this A, the reverse, and put that to the front, right? So we'll say if there is a word, right, from index 0 to I, this is a palindrome already. Then the shortest palindrome we want to do is that we want to get this part and get this one reversed, right? Reversed. And for example, if we reverse like this, the reverse, right? And then we append this part here. That will be the result. So how can we get the shortest, longest palindrome start from 0, right? Of course, we can do brute force. That will be O(n) square times time complexity. It will pass, but it is not good. You see, I originally used a brute force way. It has 700 milliseconds. So what we think about is that we should have something better. Intuitively, what to do the things linear. What there are some kind of approaches. One approach is rolling hash, right? Rolling hash is that, for example, we have this part. For example, we already have this hash code 0, 1, 0, hash 0, right? And we have calculate a mirror part of this part, right? For example, this has length L. There is this one has length L as well, has hash 1, right? So every time we add one characters to this window, right? We add move one index to calculate the new H0 exponent is very easy, right? So that will be H0 multiplied by base plus this kind of character I minus A, right? Should be very easy. And for this H1 epsilon, right? What we do is that original hash code, we need to remove this out, right? And add a 2 here, right? So that means that we need to get rid of this one, and then for the rest part, have multiply by base, and have character this kind of I plus L, right? Multiplied by base, and have this one I plus L plus 1, right? Calculate a new hash code. And we try to extend, find the longest hash code we have, right? So equal, which have a left part equals the right part, right? That means that for this H1, we may need to calculate 2 H1, right? Because it may have one number in common, just or we can, for example, this one is calculated from 0 to I, and H1 is calculated, can either from I to 2I minus 1 or I plus 1 to 2I, right? So this is a rolling hash approach. But rolling hash, even we find the hash code they are equal, we still need to compare the strings, right, whether they are reversed. That will, because there is a hash collision. For this question, actually, we're going to use another approach called Z algorithm, which we did this kind of things before. So what is the algorithm? Is that for a string S, right? We're going to have an Z array, integer array. So Zi will represent, for example, at index I, what's the longest length it will match the prefix. So for example, we have A, B, A. This is polynomial C, right? D, and then A, B, A, F, G. Okay. So let's say let's go through the example. This B, right? Does not match the A, right? So this will be 0. And this will A matches this A, so this will be 1, right? But after this one, this C, right? C doesn't equals B. So we match this C again. So C is 0, D is 0. And we see this A, right, equals this A. So this will be, we can continue match, right? So this A, B, A will match this one. So this kind of, here it will be 3, right? And this one does not match A, this will be 0 again. This will be match 1, right? So we have a Zi will represent at index I what is the longest length we can match the prefix. But the thing is, how can we calculate the ZI if we still do brute force? It will still not good time complexity, right? But the thing is that we maintain something called a Z box, right? Z box. What does that mean? Is that for example, we have this one match to the prefix, so we maintain a Z box. Left and right here. So when the I is in the Z box, we can find its prefix part are mirror index, right? So we'll see this one, how much it matches to the prefix already been calculated. It is 0. So this will also be 0, right? And if I goes here, it's still in the Z box. This is this A. So that means the Zi should be at least matched to here, right? But when we go out of this Z box, we still need to compare those kind of characters one by one, right? So this is the Z algorithm. That is when we follow in the Z box, we can skip the calculations we already calculate, right? So doing like this, it simplify our calculation to be linear. So how can we use the Z algorithm for this question, right? So we say we already have this kind of string. We reverse this string and append this one to the second part, right? So we reverse it. Reverse, for example, let's give an example. For example, we have a reference R, E, F, E, R, E, N, C, E, this word, right? So what we do is that we reverse this. What we get is we have E, C, N, E, and R, E, F, E, R, right? So what's it? This word we append as like a bigger word, right? Which have separate as a mirroring of each other. And then we use a Z algorithm is trying to match an I which can have a match to the end. That is Zi plus I equals this. Let's say this length is N, right? Equals N. That means from this index, we can match the prefix That means for example, if we have an I here, right, which have this kind of condition, that means this part will match this part, right? So what we do is that we need to have this I should be on the second part, so that will be the substring of the first word. So that we need this I should greater equal to K, right? And if we have this one match, that means, for example, we have reference. This one match to then will be equal to this, right? And we need to find the first I, right? Because, for example, these are also matches, right? But apparently this one is not what we need. It's not the longest. So as long as the I is greater than K, and we have this one matched to the end, then that will be, we can break, we find the longest. So that is this part. So let's begin to write code for this. So let's create this kind of double the mirror double the string first. Let's have the original string as S2 cherry. And we have in K equals S array dot length. And we'll have A equals to multiply K. And we're going to have cherry, the bigger one, right? Mu char N. So what we do is that for int I equals 0, I smaller than K, I plus plus, then we're going to have array I equals original array I, and we're going to have array n minus I minus 1 equals S array I, right? So we compose a mirroring array. And we are going to have a Z array, right? Should be equals mu int n. So what we do is that for let's have the Z box left pointer and right pointer, right? So what we need to find is index, which have the first matches, and match it to the end also pass the first the first half part, right? So we need to find this index. So what we do is that of course you can we can set a 0, right? Because they say that this kind of length is greater equal to 0. Let's set this one as -1, okay? And then what do we do is that for int I equals 1, I smaller than n, I plus plus, right? So that is if we are in the index is at in Z box, then we are going to have this kind of ZI should be, at least it will be positive, right? So we should have at least 0. And then it cannot exceed the right bound. So that will be Z I minus L and right minus I plus 1, because the right bound outside that we haven't calculated yet, right? So that if we are going outside of the Z box, we want to compare the characters. So if I plus Z I is smaller than n, and array Z I equals array I plus Z I. Then we're going to have we because we move outside the box, we can update our left point equals I, and I equals I plus Z I, and then we're going to have the I increased by 1, right? So what we do is that if this is I is greater or equal to K, and we find this kind of work match to the end, right? That is the first find will be the longest palindrome, right? So then we'll have index equals I. We need to break, right? So that means that we say this kind of mirrored string, right? We find this index from this index to the end. The first one pass the half, and the matches. Let's say it's another color. This part mirroring with this, right? Um, that means this is palindrome, right? Palindrome. That is well, because the first one will be the longest, so that will be the longest palindrome. So that means that we need a reverse this append to the front. So that is actually the same thing. We get this substring and put it in the front. So what we do is that we can have a string, let's say f, okay, equals new string from this array k and the index minus k, and return f plus s, right? Let's set this one as 0. Or we can have a corner case, right? If it's empty, just return empty. So that we can write a Python code for this as well. So we'll have, for example, R, let's equals S to reverse it, right? Reverse this kind of S. And we'll have, let's have a bigger string equals S plus R. And we'll have, for example, n k equals length ss and length s. Okay, and we're going to have the array plus this one multiply n, right? We'll have left right index equals 0, 0, 0, right? So what I in range from 1 to n, we are going to have zi equals, it cannot be negative, right? So it should be 0. And also cannot, the right bound we haven't calculated. So I minus L and R minus I plus 1, right? And we'll say while when we outside of the right bound, while this kind of the I smaller than I and SS the I equals SS I plus the, then we update the left bound equals I and right bound equals I plus the I, and the I, this window we should increase by 1, right? So what we do is that if I is greater or equal to k, and the I plus I, that means it match to the end, right? Then we're going to have index equals I. Then we need to break because the first one will be the longest, right? And we, for example, we have f equals ss from this k to index, right? And what we do is return f plus s. I'll put this is not. index P to index FF equals, well, this is not S plus D equals this from range 1 to n should not be 0. If this one plus and is I, so I equals I plus, then left, right, this one plus. And if we matches with the others, A, B, C, D. So looks like we didn't match correctly. Right? So let's left, right. In right equals plus in I equal. So index equals I break. S plus is left to right. Max should not be, then this is minus L, right? L bound. And right minus Li plus 1. While this one smaller than n and cos. So let's print this kind of index. That's index printed. Index is 0. Apparently, this is not correct. Index is 0 has never been matched. I smaller than and should have left equals right equals plus AI. Let's print. So we should have this outside. Yeah, so this tab, right? We have actual index index here.